There we go. Welcome to another stream, everyone. Hope you're doing well. So we just what did in today? So last stream build system was basically completed. We got the hot reloading of assets and hot reloading of shaders working, and I guess we got the hot reloading of code working as well, but the old system hooked up, which has bugs, and this is what we're hopefully fixing today. So what's really cool is we can run the build system and it runs in the background, right? And it watches. Now we can literally, here's this little cross model here that we got. We can literally like go over to scene shade, the shader. We can like do color.r equal or rg equal 1. Right, so red and green are going to be 1. And hang on. Ah, there's a compile error. Right, there we go. Let's say red equal 1. So in HLSL you can do that, but in GLSL you have to construct the vector properly. But anyways, so you hotcodes reloads basically instantly, and it's amazing. We can also go over to the cross model. We can make a change to the cross model, and so keep an eye on these. This is a 2x2 set of green blocks, and voila, basically changes instantly. So that's all very, very nice, very awesome. The only problem is the code CPU side. When we reload that, one, it is slow. It takes more than 2 seconds to recompile the binary. And two, when I stream, it doesn't quite work all of the time. It crashes. So this is something we want to fix today, investigate what is going on and try and find out how to fix it from stop crashing basically, but also to improve the speed of my compilation times as well if we get to that point. But we should hopefully find it, and hopefully it's not too much of a rework to get it working. So I can explain the current system that we have, and then hopefully that can arise some questions of things to investigate, like, because, yeah. But yeah. Any questions, feel free to ask away. But yeah, let's start off with a quick prayer, then I'll explain how the current hotcode reload system works. Father in heaven, we thank you, Lord, for this day. We bless your holy name. We thank you, Lord, for being our great provider, providing us everything we have today. This day and age that we live in is amazing. Such an easy time to live in many ways. And we just thank you for that this time that we live in. Father, help us do your will. Help us obey your spirit. And help us, Lord God, rebuke the plan of the enemy when he tries to tempt us with evil in our minds. Help us, Lord, turn from darkness to light in those situations and obey you. Even when it's difficult, Lord, help us do the right thing. Father, I just pray for each and every one of my viewers that they just get to know you, that they seek and find you, that they you know you can look into the evidence of the gospel, if your son comes to this earth and find it. And I pray that their hearts are changed and they're born again and saved from the grips of the enemy. And Father, also just pray that you help us with this project. Help me find the right direction to go in. Help me not go around in circles. And lead me into making something that will benefit the believer, the non-believer. And that would just be fun for everybody, but not taken away from the message. Thank you, Lord. In Jesus' name we pray. Amen. Cool. Yeah, so effectively off stream I've been working on a presentation as well. We are just finishing up some changes to the engine to make it such that we can prototype quickly, right? So it's basically there. I don't know what else we need after hot code reload. Um, so the presentation is also basically there. I'm hoping to record it and get it released on YouTube, and then I'll come on the stream afterwards and just be working on this new game prototype. But yeah, so I might take some time off, like one stream or two streams, to finish it and record it and release it. Because it is ready to be recorded. It's just I could make it better, and I feel like it's sometimes worth a little bit more time to do these things a bit better. But yeah, very excited. Looking forward to releasing that and letting you guys know about the game that we'll be working on. But yeah, so effectively, let's go over to this. We have a main.c, and this effectively loads the game libgame.dll. And so this main file is super slim. It basically does, what it does is load the DLL and get a bunch of function pointers like initialize, render, before the DLL reload and after the DLL reload. And it's got a few more to do with the event thread, because when you unload a DLL, it destroys all the threads that the DLL made. So maybe what we can do instead, though, is just get it to pass the create thread function. And I think we can get rid of these. And that would then mean that the event thread can just purely go in the OS abstraction, which would be very, very cool. So I think maybe let's start. This is not necessarily the problem, but I don't like the fact that we've got this whole event thread thing, and it feels like it probably creates issues with like these stupid atomic things. So I'm thinking, yeah, maybe we can sort this out. So let's see if we can just figure out. Right, so the context is we want to do, C hot code reload win32, right? This is what we're doing. Blah, 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 blah. So, right. Okay, so I want to say create thread. That's what it's called, isn't it? Yes, create thread. So create thread gets shut down when the DLL unloads. Can I pass the function pointer from the exe to the DLL to avoid this problem? So apparently you can. Yes, this could be one of the problems of why the hot code reload crashes. So does create thread get shut down when DLL unloads? No, but it crashes immediately. When you call create thread and pass a function inside, the Windows kernel creates a thread and points to the instruction pointer. Huh. I don't think this makes sense. When you call the free library, If you use create set thread inside the DLL, but pass it the function pointer pointing to the code inside the exe, it will never crash on the unload. Right. This is not what I'm asking it. This is not what my question was. So it's talking about the function pointer of the create or the create thread starts with. Right. Yeah, so this could be the problem with no, it's not because I shut down all the threads. I literally shut them all down. I'm talking about the create thread function itself and the thread handle. No, create thread itself does not get shut down or reversed. The handle remains perfectly valid. However, because the thread's underlying instructions disappear when the do unloads, handling the function pointer. No. That's not true because I've seen it in the debugger. They completely disappear when you unload. Or maybe it's not. Create thread is a Win32 API function located inside kernel DLL because kernel DLL is globally loaded by the operating system and stays mapped to your executable memory space for its entire lifetime. The create thread function itself is completely safe to call anywhere. If you pass the function pointer to, it works flawlessly, however, because are you sure? Are you sure? Right, so maybe so inside the DL, right, so inside the DLL, so there's this worker thread, that's the thread function. Inside the host exe during the reload, what we call free library, you must explicitly clean up the thread using its hand. Yeah, so you see, I wonder if we could just shut down the event thread anyway. Yeah, so if we rework the code to shut down the event thread and then just boot it back up again, potentially. Okay, I think that's the approach we might take. So right, so wake to wake it back up. Yeah. So process and there's initialize. Okay. So effectively what we have is a thread which is dedicated to processing the window events and dispatching Windows calls. So like when you want to create a window, you put it on this special event thread. And this is just because then we can do stuff like resizing the window, I think, and it doesn't freeze, or sort of, and other things, right? And grabbing this so it doesn't freeze the game. Just did it with Windows. So yeah, I think if we create a thread and then okay, so OS, is it backend in it? Right, so here we want to create a thread init, I think it's called. Yeah. OS thread spec. Now, which one of these guys do we need? Not sure how if we need really a megabyte, but let's say 64K, maybe that's enough. Cool, so the thread we'll use would be wait, this never happened then, did it? Okay, so event thread main. There it is. No argument. We'll call it the event thread. Now, I think we'll store in GOS Windows. We'll call it the event thread. Lovely. When we initialize the whole operating system layer, we'll boot this guy up. Now, we actually want to stick this function somewhere. So let's try and keep in order. Now, if it's not initialized, there's an event thread in it somewhere. Yes, this is what the DLL the executable currently calls directly, and it sort of creates some things. What does it do? Yeah, it creates these. Are these stored anywhere sensible? It just creates a couple of classes. Right, so the request, this can be our thing to tell whether or not it needs to be initialized or not. So I think we can take all of this, and we initialize this on another thread, one for speed, but also I think so it belongs to that thread as well, something like this. I forget. You can have it work. Is that right? Am I right by saying that? Maybe not. It might get joined at some point. We'll see. We'll find out. Backend in it. Hey, this one I put it in. Right, so here we can just say if now what is that? HWND, right? So what is the invalid value for HWND? 0 or -1? 0, amazing, and it's already 0 when you boot, so nice. Next. Initialize all of this stuff. There we go. Now the next thing to do is put it in a loop. So if we go back to the main.c, there's this sort of event thread loop. Oh, this would be awesome to get rid of. Okay, so it's just a while loop, then around process, and there's this whole paused thing. Right, so we take that processed thing, process, event thread process, here we go. Get rid of all that. Oh, it was actually just above where I was the whole time. Okay. Right. So initialize thread local storage. Yes. Yep, that's right. Then keep looping around here. And we want to basically shut down, right? So we need to have a way to know. So maybe it is via an atomic. I don't know though. We'll find out. Yeah, so the job system actually does, it'd be an os.c. I think there's a join somewhere right here. Yeah, so we say is reloading. Right, so I think what we want to do is have in the operating system thing in general is like, okay, we reloading, and then it can check that. So it shouldn't really be on the thread pool. So on OS, we'll just stick Boolean here. We'll just call it like is DLL reloading, something like that. And where's this located? Huh. Threads DLL before. Okay, we'll go in here then. Oops. Yeah, so GOS after reload, an atomic store as well. But it's true. Sorry, false here. So after reload obviously gets called and the new DLL has been loaded in. Then this should kick off, yeah, start the workers again. So we want to, here would want to start off the event thread main, so here. So maybe we can have another function called like OS Windows event thread start, right? So we'll find the thread main. OS Windows event thread start. So it just kicks it off like so. Now on the after reload after. See, that's interesting. There's a threads thing. Store false first. There we go. So where is this called? Right, so it kicks the threads off right at the end of the reload. That makes sense to me. Right, so we're nearly there now. This is awesome. So there's this whole wake thing as well. So we want to be able to wake the thread. Yeah. We need this. We're not going to export that either. No need to export anymore. So wake and start. So before the DLL, where is it called? It's before. Yes, you say, so you wake it. See, this is going to wake all the workers, then go over them, wait for them to join. Then we'll wake the event thread, and then we wait for the event thread to join as well. So that is in OS, Windows. Yeah, amazing. And we kick it back off when we load it. So I think that is, I'm pretty sure that's the event thread code brought into the DLL now. And maybe this is the problem, I don't know. Yeah, so GOS Windows, sorry, OS is DLL reloading. So the DLL is reloading, break out here, terminate the thread, and then we'll reboot it up again. So the question is, yeah, we'll try this out. But I remember when I was doing this before, when you killed the thread, when you killed the thread, all the window handles get destroyed. Ah, maybe that's the issue then. But wouldn't terminating the thread destroy the create windows? That was the problem. Yes, absolutely. If a thread creates a window and thread terminate, yeah, so this is the issue then. Interesting. So what ways can we do that? Can we do it then? So we could have the function pointer that lives outside of the DLL inside the executable, and it returns from there. Right, so different ways. So the host.exe calls create window, runs the message pump. Nope, not doing that. only handles rendering logic passing. Right, if your Windows must live inside the DLL, not reload your input, window handling, and still not destroy the thread. Instead, you change the Windows function pointer dynamically with set. Right, so you create the window with that. The DLL, when the DLL loads, you do set this to take control, right? With the messages. Before it unloads, you set it back to there. So the window. Hmm. Wait, so could it be crashing on my... No, because there's no message pump. Yeah. So I was thinking like, could that be the cause of reason why my code sometimes crashes? But if I currently pause the event loop inside the main executable. And so there's no event loop processing those events, so it's not going to be running that code. Hmm. So we could just have a function which lives inside the executable, and that function is what the thread starts in. And then when you want to shut down the thread, you return from your function. Right, let's just, so maybe you have a function called like, let's call it main thread function, whatever it is, and it passes in a void pointer, right? There's the argument a. Then what you could do is convert it to a function pointer, which is like, right? So you convert it to this sort of function pointer, and then basically call it. And then it only returns from here when it needs to reload. So this would be inside the main executable maybe. And then that will keep the thread alive, so the thread handles won't be destroyed. But then you somehow got to keep it spinning here until the until it's reloaded, basically. So I guess you would just spin. You'd still need those atomics that you've got in the system at the moment. But then that would move. So you'd have to pass this into the game like a function pointer, basically. To all of your threads that you want to keep alive. This could work, but it's just a refactor from what we have. Not sure it really solves our problems at all. Alright, let's go to the game main. So yeah, currently we loaded up 3 different function pointers to do like init and wake and process, right? But we wouldn't necessarily have to do that. Yeah, I think maybe we can just export. Yeah, okay. It might be better. Yeah, let's do this change. So main thread. Let's do that. Let's move this into the game executable. Like this. So we take this, and we move it, and we can just pass it into the game somehow. How do we do that? I have to pass it through a few layers though. Persistent. Why is it persistent? Yeah, is it ENT or? Yeah, it's E, isn't it? Persistent thread function. That's what we'll call it. So it cleans up the code a bit, but I'm not sure it really solves any problems. So just cast that into void pointer, we'll recast it out when we get to the other end. Okay, that's very cool. Now the next thing to do is to actually put this in game init, so it's in game.c. Then into OS, we need to pass in this sort of persistent. Oh, that's TLS. Whoops. That's one. Yeah, probably. Cool. So that goes into the operating system layer, and I'll go into backend init as well. Right. So here, so this thread start. You know what? We don't have to pass it in. Not the best thing to do. Just put one of these in. Lovely. So inside OS Windows, we can basically we put this here, this main function, that doesn't have an argument anymore. It's just void. There we go. And this we put as the argument. Then, oh, you don't take addresses. Okay, good. And then this will use the GOS dot, what is it called? Persistent thread function, okay? So OS thread main function, that's what we get cast into, okay? Now, in game.c, sorry, in the game main.c, now what we can do, yes, we don't take the address, that won't work. Cool. So we need, yeah, so when the render function returns and says reload, it will store is reloading into this atomic, then, so it doesn't have to do this wake on the render thread anymore. That doesn't need to happen, which is very cool. So it reduces this stuff that we need. And reduces these silly things too. So this whole event thread thing goes. Get rid of this here as well. And then, oh. So there we go. So it's heavily simplified now. Get rid of thread initialize. No longer do we need that custom function. So now we've got less sort of Windows specific stuff inside this small plugin loader basically. So we call into the function pointer which initializes the game. That's in lib game.dll. We just call the render function, right? We keep calling it until it tells us we need to reload. So the render function is going to obviously call into Vulkan. It'll grab the latest payload, call into Vulkan, and then record a command buffer, send a command buffer off, and you get frames like these, whatever. Then when it needs to reload, it will tell us. It will then flip this bit to true. Oh, hang on, I did delete something that I need. Yes, then it flips this to true. It does DLL reload before function. This is going to go through absolutely everything and clone the game.c. Yes, the first thing it does is shut down all the threads in the system. Shuts down the workers, shut down the event thread now. Then it goes and backs up all of the static memory that we use into a piece of heap memory. Right, so it doesn't belong to the DLL in any way. And then it unloads the DLL, loads the new one. calls the after function to copy the static memory back from heap to the static memory of the DLL, which is all initialized to 0 when it boots back up. Then it will so it replaces those zeros with what it was before it reloaded. Then it reboots up all the threads, right? So after that, yeah, so we can't shut down the event thread then. We've got to remove that code. And then it sets is reload to false. And this event thread is still running because it used this main thread function. And so now the code is running in here. We want to make sure though, getting a new function pointer though, didn't you? Damn it. You need a new function pointer. Right, so instead then, so you can pass in a string and get it to reload it. That way. That's a possibility. You can get it to load the function pointer based on a string from the DLL. And then that would do it. Then it can reload the new one. Okay. Okay, so that will probably be the solution. So arg would just be a string. So essentially you would just have you get yourself one of these P's. So you would pass in a char. Now the issue is that char is going to be destroyed. So you want to have a little char buffer locally. Just call it name. We'll make it like, I don't know, 32 ought to be good enough. So you literally just string copy it straight into this and name arg, right? And then now you've got a little local name. What are you talking about? It's smaller than type int. Oh right, it's not the right one, is it? Where is it? Get proc address. Cool. Yes, this is the one we want. So instead now, in os.c, interesting, why does it, oh, OS Windows, that's the one. So rather than, what we do is we pass this in as a string. And now it will be able to look up that, but this has to be export. So core export. That's gonna be awesome. All right. Cool. So what will be next? What will be the next thing that we can do? So we shouldn't be terminating the thread anymore. So this start function no longer needs to exist. So we'll get rid of it. So in initialize, it's going to obviously run that code. And when we we never join, but we wake it up to break out. Yeah, no longer start the thread back up now. Oh. Yeah, we need to event thread wake such that it wakes up from the main and returns, but it never terminates. It gets called back again. Beautiful. Okay, I think that would be a new way to structure it, but I don't know if it really solves our problem of the game crashing while we're streaming. Maybe it does. But now we don't have a create thread function inside the main C file. It's less code. There's less booleans floating around to handle state. We simply have this persistent thread function, which gets the proc address. When it needs reloading, it returns from this function again, waits till the reloading is done, goes back around, gets the new proc address from the reloaded DLL, and goes again. Right, so that's quite nice. I like that solution. So let's try this and see what happens. I went to my build system. Why is it doing that? All right, let's investigate this. This is not nice. So the cause is Windows internal. Oh. Weird. But did it only happen a few times? Oh no, sorry, they're two complete different executables. One's this main, the encoder codegen, which should not be using this system, but it is anyway. Oh well. Yeah, my encoder codegen is probably, yeah, it's just silly. It's using parts of the engine which it shouldn't be. Anyways, so os.c. Ooh, what a problem. Yeah, so it started trying to reload the CPU code here for some reason. Look at that. Rightio. So it seems like it did get stuck. If we just try and reload the OS. Right, I had to rebuild so much for some reason, I had no idea why. Oh, but apparently that's still... because if you change os.c, it changes the whole encoder codegen. Right. Let's change more of the... So because the encoder code generation uses that file, it recompiles that. Then it recompiles all the code generation. Then that triggers all these shaders to rebuild and the whole game executable to the whole thing. So we should probably remove that dependency. It's not very useful. But... Oh, that seems to be alright. So it is reloading the code then. Right, so could I go into game.c? Maybe this will solve the problem, I don't know. I did see it freeze though. When we booted up the game. Yeah, so let's find like the orbit cam. This is a good one to look at. So this is on the tick. So if we basically make this one, it should just keep rotating. Right, I think we've got a crash. No. Yeah. Sad. So let's have a look at that, see what's going on. Right, let's just put that there. So only when I go to grab an event. Oh, okay, so it seems like the reload is happening fine. It's just now when we grab an event, it's wrong. So that's because the function pointer it's trying to use for the window events are pointing to the old memory address of the old DLL. So there is a way to do a set window long pointer thing, right? This thing. To reset up those function pointers for Windows, and I think that'll do it. So if we go to OS Windows, now we find what is it called? When the event thread gets initialized in this one, so we can do an else. So this is on a reload. So we want to iterate over all of the windows. Is there an iter? There's an OS window in it, I think. OS. Yeah, in the operating system layer, there's like a list of windows, I think. Or it's inside a packet. Yeah, so inside the packet, there's a stack of windows. So we can go over that whole stack. And I think, yeah, I think that's what we can do. So a packet is basically like a snapshot of all of the state that the operating system that we know about the operating system. So we've got like a list of windows and inputs and stuff like that. So we can pass it around thread safe. You know, we can be building one in the event thread and then giving it to the game. The game can do its thing, then it can give it to the renderer if it wants. So it obviously has a bit of latency with it, but we try and feed the renderer more up-to-date mouse position later on, I think. Or we can always do that later on. So there's things we can do to avoid latency and stuff. Or sorry, to account for the things like this latency that get introduced. So yeah, we can like go over. So OS packet Windows stack count. This is the guy. I want to go over here. Then I think we could locate. There's like in Windows internal. I think there's another pool. Yeah, there is. There's a pool for the backend Windows stuff, which has the HWND handle, which is the one we want. So I think there's a get function for this. Lovely. So we can literally just call this. Call it W. And we simply just say GOS packet dot window ID stack dot data index and voila. Now there's this new function that we've found where you can replace the event loop thing. I could stick a comment here describing exactly what it does, but that would be silly because the code looks kind of self-explanatory, right? You can just read it and use Brain, and Brain tells you what it does, right? You know, it's like WND proc Right, so it seems like we're setting it, and this is in the block, which is after hot code reload, so ta-da. So that would then be... Now, my question is, though, like, is this... So this one is a class... Right. And there's a request HND proc. So which ones use this class? Right, so this one here, the request needs to use a different one, so we'll sort that one out as well. So that would be the request. Amazing. I think that's all of them. There's a raw input as well. Where does raw input get done? Amazing. Right, let's try this. This should hopefully fix our freezing problems now. When we reload. So we've got a game. Man, we've got to fix that problem. It's only done. Right, so it keeps on rotating, yeah? So if we simply go to game.c, we comment out this. Oh no, it's frozen. No. So I wonder if... Find out why. So there is also this sort of like the stack trace thing, you know? We this is my stack trace handling code, and I wonder if this sets up any function pointers or something. Get how it works on Windows. Right, what we're looking at. So get stack trace. I wonder if it's failing to get a stack trace basically when you reinitialize things. This is interesting. Does this of the DLL? No, you should never call this again after a hot reload. In fact, calling it multiple times on an active process without calling cleanup first is explicitly warned against by Microsoft and will result in an eternal memory corruption. Okay, this is interesting because here we have a static variable. This will be reinitialized to 0. So on hot code reload. So I imagine like this could be the reason why. Yeah, so we potentially need a cleanup or a sort of shutdown or DNet or thing for but there is like a null. Hang on a minute. There is different parameters though. what do they mean? So there's a null and a true. Doesn't that invade process? Oh, so invade means when true, it enumerates the loaded modules for processes and effectively calls the right. So it checks all your processes that sub processes maybe, I think. I'm not sure exactly what that means, but it's not related to the problem that I'm thinking about, I think. Yeah, I think we have to. This static piece of memory here is a bugger, basically. It would be cool if we could look around all the pieces of code for stack. Then again, we wouldn't have found it if because it's in the third party folder, which is get ignored. But yeah, I think we could use a program though to find all of the static global variables, and that will help us track those down. I typically try and make them big old static blocks that I can unload. Anyway. But yeah, this is going to be causing us problems. So, Windows, find all static variables of a DLL. That's what we want to do. Right, I'll be right back. Just going to get a refill of my drink and stuff. And then we'll hunt these guys down and sort them out. Right, welcome back. Okay, so we found the static variable, which is probably causing us issues on the reason why. The stack trace is not showing up when we crash after a reload of a DLL. So I think in bstack trace, which is this single header library that we're using, it's cool because it does the stack trace code for us, basically the code you'd write anyway. So I'm glad I found the single header, because I had my own before in the past, and then I couldn't be bothered to re-implement it, so I just looked, and there was a library that did it for me, which is rare to have basically the code you'd write anyway. But we'll just modify it. We'll have a sort of a way to DIN it. Oh, do I use that in... How do I do it then? I just use this one. Okay, yeah, but it does it manually. Right, okay, cool. Right. Anyway, so we want to have a way to basically DNet the whole system. Right, shut it down. So that would just be if called is a cleanup. Sim cleanup. Yep. So we just stick that here, and we call it over in game.c before we reload. So right here, yeah, right at the end, so we still get stack traces, and we just DNet it right here. Then it will automatically set up after reload. Yeah. So try that. That should help us get stack traces, maybe, or maybe not. All right. We need to get rid of those dependencies on ENC, on the encoder code gen. So if we go to game.c, we find that orbit cam. We initialize the T here and reload. So that should get it spinning, but it doesn't. And it kind of crashed again when I went over to the window, so maybe that's still not solved. The rebuild game changed it. It did a complete or whatever, but then did it really complete? Because I didn't see no update. So tick. Oh, this is interesting. So I don't think the game logic thread gets shut down. Oh, this is interesting. Yeah, so with yeah, I've never shut down the thread. So this needs to be shut down now. So we need to somehow terminate this guy. So we want to say like atomic load. No. What are we doing exactly? So before reload, is the game even being backed up? Yeah, G game, it's right here. Yeah, so we need a G game before we need one of these basically. Game DLL before reload and then an after reload. Hey, Colonel J, how's it going? Nah, we need to shut down, unfortunately, because in the boot the thread's back up. If not, the pointer, the function pointer for the thread function is pointed to the old DLL location. But yeah, it won't be good. Making it crash and burn. But yeah, how's life going? What you been up to? Alright, that's looking pretty nice. Now, here is where we do the shutdown. So, I don't know how you do it though. We need to find a join. There we go. G game. Is there a thread? There is a logic thread. That one. Good. Awesome. That's good to hear. Yeah, doing quite good. Yeah. Yeah, life is great. Really, no problems. Yeah, nothing to really complain about. Yeah. So, been working on this sort of presentation off stream, and it's ready to be presented, but it could always do a little bit more work to make it more presentable and higher quality, shall we say. So I'm just in that phase of just making it better, just refining it. This presentation will be of the game idea that we're going to be working on very, very soon. So I'm literally just wrapping that up, and we're so close now. We've got the build system done, right? It's the shaders reloading, the assets are reloading while the game's running, which is very cool. It's just the game code is not reloading properly. It's crashing and burning. So we're sorting that out, trying to make it go fast as well, because hardcore reload, which is slow, is not nice. But yeah, it's gonna be cool. I'm excited to actually work on a game. Also the backup stuff. So the backup stuff is backing up the global variables. So the global variables, when you unload a DLL, it obviously wipes the memory, then you reload it back in, they're all initialized to 0. So we back up all the globals and then we restore them. So we back them all up into some heap memory. So how do we tell this thread to stop? It kind of sucks everything needs like an is reloading boolean just floating around. So it would be nice if that was just in core somewhere. You know, we could just say G. Yeah, core dot. Here we go, core.h. Stick it down here somewhere. Extern. Boolean. G. Is DLL reloading. That might be the way to go. Yeah, some people don't like globals, so they pass all these like pointers around into all their functions and stuff. But I find that annoying. Like, I kind of have a rule where if there's more than 5 parameters in functions, I put all of the parameters inside a single structure. So by always having an extra argument around really forces that to happen too much. So yeah, I try and, especially in games, just you have a lot of like, you can just have like big old structures that are in globals and It's fine. Yeah, I have a rule where I have one global per module typically. Obviously, I just broke that rule, but you know, rules have exceptions. So yeah, I think you'll basically kick that off with a I did that one point when I started making an engine, probably why I quit. It blew my mind, just the whole thing. Loves to do it again. What are you talking about specifically? You talking about the hot code reload or passing variables around? Right, okay. Right. Yeah, it's difficult. It adds it like uh just adds more. It was I was concerned at the time because people in my chat was like, I'm reverse engineer that, you know. What do you mean they could reverse engineer it? So what does that even mean? Like, how does that? Why is that a problem? And how could they reverse engineer it anyway? Um, like, what makes it such that passing variables around will prevent the reverse engineering? That's what I meant to say. Like, is a global variable more accessible? I guess so. Yeah, it's you can like read it in the DLL. You can probably get the maybe. Right, okay. Funny times. Alright, get rid of this thing now, which is amazing. Right, so now we can call this like G core deload is reloading. Get rid of that. Oh, and do stores. Of course we need to do stores. Hang on a minute. Stop doing a silly. Right, any more of those guys floating around? I think there is. The os.c. Just in one place. Lovely. So now, atomic load. So you can probably just make that a function, right? Why are you doing this all over the place when let's make it macro. Done. Sorted. Nice. Cool. So this means then inside the game main function or whatever it is, we just say while it's not reloading, right? And then this one exits and then we join. Right, so this will initialize it if it's not already initialized. That's cool. Then where's the join at? So the game. Oh, it joins it there. Beautiful. Beautiful. Now the issue is this needs to be set to invalid such that it gets reinitialized the next time around. Oh yeah. Also in core.c, ah, crap. Let's just put underscores there. Do I have plans on encryption? Maybe, but it depends. Certain places, yes. But was my next question. What are you doing if someone tries to source code your? Yeah, I do use AI, right? Don't get me wrong. We've been using it today, but I use it as an enhanced Google search and to help me like find answers to problems. But that's about it. But that's only when I need it, right? When I clueless, which is rare. Thank you. I just had a lot of practice, but yeah, I'm stupid compared to God. Put it that way. I'm a foolish man. Yeah. So basically, the source code to this engine is available, right? For people who support the stream, via this link right here, they can get access to the codes run on their own local machine. So the source code to the engine is available, so it is already kind of hackable, right? So there's a thing where it's like when this game gets released and whatever, it's like then, you know, I don't think it matters how much I encrypt it, but it might. There's certain things I will need to encrypt if you're doing like multiplayer or something, right? To stop people hacking it. But I think you're only playing with your friend anyway if we did multiplayer. So it probably doesn't really matter that much. It's like, what, like you're cheating against your friend or whatever, which is like, you solve that problem socially, right? If someone keeps hacking against you and it's your friend, you obviously just find new friends, right? But that's nice. I just hate seeing hard get abused, I thought. Yeah. Yeah, exactly. Just get the low hanging fruit stuff and that should be fine. Yeah. So should this be be it working now? The logic thread is getting shut down. Now we'll get rid of this thing. Oh, this is nice. We got an assertion now. Amazing. So yeah, sorry, we got the call stack stuff kind of there, which is great. That's what I meant to say. No, we haven't got the core stack. That crashed. Right. Right, how did this fail? So it's not reloaded. Oh, probably because it didn't exist then. I don't know. Maybe it did. Right, so where's the thing called? So it's like orbit. Comment that out and reload. 2. Right, so third shutdown. Thank you. There's no game yet. I'm glad you love it. There will be a game coming soon. Very soon, hopefully. Oh, this sucks so much. Why did you want to join? And the reason? OS results string. Go on. Tell me. Hey, Podvig, welcome back, sir. How you doing? Happy weekend. And it's work tomorrow. Most people. Alright, here we go. Come on. Eh. Come on. Oh, we actually got stack trace this time. Error unknown. Plus, that's obviously a very helpful error. Professional. Yeah, I just got a nice sky shader. I guess. Yeah. It's got like a little window thing. You can do, you know, the docking stuff. It's cool. Yeah, when we're doing the game, we can like make a new docking window for like debug stuff and like, you know, it'll be fun. To do proper error reporting. Right. Right, let's get another. How does one? Let's see what it does, because reading the Windows docs is horrible. And this is a general function. So it's saying that successfully waited timed out only applies if you use timeout instead of infinite, right? Failed, then you do get last error. Okay, so it should just be get last error then. So it'd just be that. Ta-da! No. Yeah, so sometimes the hotcode reload runs when you boot the game up because it's got a set of files was changed. I did kind of solve that problem though, but it keeps coming back up. Right, here we go. So comment that line out of rotation and go. And you don't want to tell me? So maybe now what's happening is the thread is trying to report the OS error, but there's an assertion, and then it's not reporting the assertion for some reason. Right. Let's yeah, it's most likely there. So like in Windows there's sort of like get last error thing, and I reckon, right, like there's part of an issue with this where it's been crashing in the past. It's been crashing in trying to print. Like sometimes the standard out handle just when you try and print that, it crashes. After the hotcode reload, and this has been part of the issue that I've been trying to deal with. And so what could be happening is that, and it's probably on this guy right here. But I don't understand. Yeah, so I guess let's look at some more. We could look at some more of these statics. Right. Oh, maybe just run it in here. Game run. No, run the build script. Yeah, because run the build script, we can debug the child processes and then it will work. Cool. Nice. There we go. Oh, is it duplicate cases? I don't know. No, the different one. File and path. Yeah. Yes, let's reload game. Yeah, the same length. Easy mistake. The build system's waiting for changes. Right, where did you crash? Somewhere. Right, look at all these threads. Right, this thread, getting the time. So it crashed getting the time. You crashed getting the time. I can't see. Because it's in CPU code reload started. So it's not even reloaded yet. Yeah. Nah, mate. No time. Ain't got no time for you. So it would have shut them down, tried to do a join, but it'll be a no. So this is interesting. What is... Oh, that's not even... Hang on a minute. G-core... Is reloading is this. This is interesting. So what is game thread... Ah, C++. Ugh. This one. Load DLL. Hang on a minute. So it's already unloaded the DLL. So that means then the unload never worked? Huh. So you're telling me it never quit? Weird. Very, very, very strange. If it's not reloading. Oh, right. So I think it should be joining the threads here. Okay, whoops. So I want to shut down all the threads first, right? Shut down the game thread, shut down the operating system thread, so the event thread, the workers for the thread pool. That will be better. But I don't know how it didn't get shut down though. Right, let's try running the debugger again. Cool, there it is spinning. We find orbit. There we go. Ooh, that appeared to have worked. That stops the orbit. And did a start and complete. Nice, let's just keep doing it. So let's change. Let's put the orbit back. No. Yeah, somewhere. It's progress. At least we hope. Right, this bugger's in the way. Crying out loud. My life. Oh. Okay, so hash table. Ooh, there's another function pointer. This is fun. Right, so every single function pointer in the entire code base needs to be reinitialized properly to point to the new function pointers. Isn't that fun? They need to use the new DLL function pointers. That is a bugger. So I have hash tables in places where they have, you guessed it, function pointers. You don't understand how hash tables work. They're not too hard. But yeah, so like in so because I want to support a different key type, I use function pointers to basically determine that. I think I've got some easy code. I can show you it. But yeah, we know what to patch next. we're getting places. So if I go to my build script, right, I've got a hash table in it, HT. So essentially, right, you know what a hash table is, right? You've got a key value, which could be like a string, and you want to get another value out. You want to map that string into another value, right? So all you do. So I've got this key compare function and a key hash function. So this will obviously return a U64 hash of that key, so that string. This will return a compare. It will compare them and return true. So some people write hash tables where they don't have a key compare because they're relying that each hash of that key would be unique, right? And that means you get an extra, like that's it's a hyper optimization, right? They want to make it even faster than so they basically try to avoid hash collisions as much as possible. Oh, sorry, completely. So maybe you know the data ahead of time but yeah, just let you know that's an option. So you basically have a special hash value of 0 meaning empty and 1 meaning tombstone. So you need a tombstone if you need to remove elements. So essentially how a find works is you typically would make the capacity a power of 2. You can do prime numbers and stuff. Some people argue those are better, but we're doing powers of 2. So we take 1, that's the mask. The basic idea is you get a hash of the key, so you basically hash the string using FNV or something like that, or a CRC, and you get your hash. Now, if the hash is one of the special values, we just make it go after the special value, right? It's a very rare case, but it can happen. Not re-init. I don't need to reinitialize it. I just need to pass in the function pointers. I just need to reset up the function pointers, but the memory is, everything else is completely fine. So so this function pointer will crash when it gets called. And then how a hash table will basically work is you take that hash, you AND it with the capacity, and this will keep you inside of the range of the elements. So you're essentially finding a random place, a deterministic random place for that key to land inside this big old slab of memory you've allocated. And you essentially check, you've got an array of hashes, and you check at that index you've been given until you find an empty and you break, that means you found nothing. Or if or if the hashes match with your hash that you're looking for that key, so the one at this current slot, you check. So you're just doing integer comparisons. Then if the hashes match, you also compare the key, and then you return the value. There's other things you can do as well. Some people say you don't like doing an and doing a mod instead. But this is the basic idea. And then you keep this is called probing, where you basically move to the next element and you mask the index back into the array because it could have overflowed, and keep going until you find it or find an empty slot. And then you have ways of inserting. So let's talk about remove. So remove, you basically do a find, but when you find it, you mark it with a tombstone. And the reason is because you can't put an empty in there, because if not, you will cause a future find to find an empty and stop looking when your element could be past a previous element which was removed. So when you find a tombstone, you basically just ignore it and move to the next element until you find an empty, if that makes sense. But yeah, you have to play around with the implementation to understand it maybe and see visuals, but this is basically how they work. And an insert is just going to do a find, but it also looks for a tombstone as well. And if it can if it cannot find an element to if it finds the element, it basically overrides the value. But if it if it doesn't find an element, it will basically insert it where it found the first tombstone, or it will insert it at the empty slot that it found. And that's basically how hash tables work. They're kind of cool. Like, they're quite fast, but obviously an array is like way quicker. It's quite a clever idea, hash tables. There's other things you can do with like if you want like a growable hash table, you've got to like rehash all the values back in, but you just basically avoid that problem by pre-allocating the max amount and don't resize the capacity if you can. That's what I do. Yeah, good fun. Anyways, so we've got to find every single hash table that we have in the whole code base and then reset it up. So it's not too hard because everything has like a DLL reload after. So realistically then all we have to do is search for core hash table and find them. Right, so the UI has these two guys. No worries. Yeah, so they're right here, yeah? So after reload, plop that in there. Now we're looking at doing basically dot right, so it's like key hash function equal that. I think that's all right. And it's key compare. Right, so it's one module. So I think the graphics one does it as well. Right, so UI, that's sorted out. There's another one. Style glyphs. Okay. Cool. Let's go to the next one. So there's one in OS, internal, I think. OS Windows, maybe. Here we go. There it is. So that'll be after. Oh man, there's actually another one we missed. We'll sort it out. There's three function points. There's a few of them, I think. There's a hash function. So you can do a different one other than FMVC, right? There's the key compare, sorry, key hash and the key compare. Oh, right, so let's go back to where we were. So these just want to be using FMV basically. Right, let's just plop those in there. It's difficult to read. Right, so we could just do this to make it easier, right? Anyway. Nice, so let's keep going. So we're in like a core hash table. So we've done the Windows internal graphics. Is there anyone that seems left? Yeah, it's just graphics. What about graphics.h? Okay, so in the payload itself, so all those payloads that we have, the payload queue needs to be reinitialized. Sorry, those function point need to be updated. Then, and inside of the voxel cache, the material cache. Okay. No biggie. Not too hard. Right, let's get all these things done. So that will be cache. Okay, so that'll be hash function key hash function then key compare function. Now I just got to get these cache things right. So this would just be ggfx again, material cache vk. Cool. This would be the same thing. This would be, I think it's voxel, so ggfx voxel cache. Amazing. Cool, liking that. So those should be the hash table. Oh, one more. So in graphics.c, this is like the common interface. If we did different backends and stuff, other than Vulkan. So there's a payload. There's also a payload cache. Sorry, not payload cache. A payload queue or something like that, right? Oh, is there an F? Don't think so. Amazing. Thank you. Thank you for keeping me up to date there. Ah, the payload queue. Yeah, so when we do the payload queue, what do we do? So you reload. So we're probably do payload queue, DLL, reload after. I think we'll just make one of those. Right, that might have been the machine getting hammered by the language server protocol, maybe. Yeah, maybe. Graphics payload. Right, P. Where's the hash table? Oh boy. Hash function. P key. Hang on a minute. This one, voxel model to location. I missed that. Key hash. P key compare. Is that it? Now we need to call this guy after we reload, so let's go to game.c. So every single time I do a hash table now, I have to remember this. If not, it will break reloading. But there we go. I know in like Visual Studio they have ways to automatically like do hot reload and stuff, but yeah. And it deals with a lot of things automatically for you. Nah, it's not vodka. It's just water. It's a nice big glass bottle. It was I forgot what country it is, but my mum went to I think it was a country in Europe. I think it's maybe it was, yeah, I forget. Anyway. And yeah, she got some glass bottles like this. They're good. They're very you know, it's not drinking from plastic, and you know, just take it around with me as well. Payload cute. Right, here we go. Now hopefully this works. So we go to the, oh, where are we going? We gotta go to game. Right, obviously we enter the game. Orbit Cam. And here I thought a fellow alcoholic programmer, nah, that would be a sin, unfortunately. So, you know, I can drink as a Christian, but you just can't drink. Like, you shouldn't drink to get drunk, right? That's the idea. See, for me, when I get drunk, I don't get like these days if I drink, I would it would affect me, like even after one drink I'll feel it. But I used to be able to handle my drink quite well. And also didn't really exhibit too many bad problems from it. Obviously, you'll say things you wouldn't really say. That's a bad issue. But you know, I wouldn't get aggressive, or I wouldn't get I'd get more laughy probably. But yeah. But yeah, that life is behind me now. No need to drink. Oh, look at that. It Hotco reloaded. So it's faster. Yeah, so I think I'll just make more of a fool of myself, right? Rather than trying to be a beefy male who's like drumming his chest. Yeah. Yeah. Comes with the territory, right? Yeah, I remember like drinking so much before where I just started like it was really bad. No. Yeah. Yeah, I remember once I got so drunk. I remember getting like one more drink from the bar, and literally I just couldn't even keep it in my mouth, you know, just came out my mouth. But yeah, I'll do that stuff again. Oh, no point. Foolish. Yeah, you should really It's not really wise to do anyway. Yeah, I think we got hotcode reload working. I don't know what I did to fix it, kind of. Well, I kind of do. I kind of know what I did. Don't do this to me. No, it crashed. Just as I said it was working. Received 2 directory type. Oh, no. The build system crashed. The build system crashed. Okay. This is fine. Yeah, so build system. Received 2. I don't realize I wrote that stuff down. So, right. So we could just say if it's new. Right, it should stop trying to be so correct, right? If it's received 2 times to remove the same file, then who cares, right? Just remove it once, right? Yeah, I think that's cool. That's cool. Now, yeah, there are sometimes when it tries to. Oh, it hot reloads when you boot up. Sometimes it's a bit dumb, but there we go. I've tried to solve that problem. Maybe we can try and solve it a bit better. No. Okay, it's still not stable. Yeah, it's the LSP then. Maybe. Oh yeah. Yeah, when the game freezes, it like yeah, it does stuff. Too much stuff. Like the OS, I think it is. Like especially when you bugger up stuff on the GPU, I think. But yeah, if we don't have this being stable, then it's not good, right? But the reason why it might have done it, that's the way of saying it. The reason why it might have crashed is because I think it tried to hot reload when you started the game or something. Maybe. But maybe not. But this is cool, this is working. Can we do like a -9? What happens if we do -9? It goes the other way, right? Right, that's cool. Right, so I think it's fine. So if we change the file then, now. Oh. Oh, then it hot reloaded. Ah, crap. Yeah, so if I change the file here. Right, let's close that. Do you push to Git? Yeah, unfortunately I use Git because it's like the easiest free thing that you can use. Like I use GitLab and they give me like 5 gigs of free space for each repo. So I've got a third party repo where I stick all the stuff which is public anyway in that one. And the idea is that when that one gets too big, right? After having 5 gigs worth of Git history, I'll just throw it away and then do another one. And for the game though, the idea is to hopefully not have 5 gigs worth of assets. And if I do, then maybe I'll put it out into different Git repos again, or then I'll do something else with the source control. Yeah, maybe I'll keep using Git and do a local one, or I'll do something else. I don't know. But yeah, Git is a Git. Put it that way. It the interface to Git, the user interface is kind of crazy. Right, you can accidentally just destroy all of your work, and then people will just say you're doing it wrong. No. But the whole point of source control is to... Right, maybe you can't hear me because... Right. Yeah, but the whole point of source control is to preserve your code. And if Git does a good job at destroying your code sometimes if you're not doing it right, then yeah, it's not very nice. I should always create backups and stuff. But yeah, so I basically try to use as little Git as possible because I don't want to like shoot myself in the foot. Like I literally just Git push. That's it. I would, I would do branches if I work with more people, right? But and then merge back. But I wouldn't bother doing the rebasing stuff or whatever, right? It's just too much faff. Yeah, so the problem seems to be happening when it does a reload right away. So literally if I save it, it's gonna compile it, boot up the game, and then it's like, oh, I'll go reload. And now the next time I try and hotcode reload it, it crashes. No, it doesn't, damn it. But that's been the only time it's been happening. So I think maybe what the issue could be is yeah, where else does the codebase have function pointers? There's obviously Vulkan, right? But those are different, I think. Okay, maybe it's fine. Oh, let's just say it's fine. It seems mostly alright. So the next problem to solve is it takes 2 seconds to compile. It's kind of criminal. So what I want to do is do a -v and see. I want to get this guy right here, you see? Take it. And I want to do a oh, don't do that to me. Right, here we go. So I want to do a -e. So this out thing here. So -e. All right, so build game.expanded.c. I want to get rid of this dependency stuff. Get rid of the library stuff, wherever that is. It's near the front. Get rid of the linker stuff, get rid of the shared stuff, I think. And yeah, Dashi. So expand, thank you. So we open up build game expanded C, yeah. Here it is. So it's about 173,000 lines of code. All expanded, including Windows, headers, and all this, right? Windows headers are about 50,000, I think. But we removed it and it like took, what did it take? It's about 300 milliseconds time. So we're not really saving much if we reduce Windows to H and stuff, right? But yeah, there's things. You know, there is some of these generated headers and stuff. I wonder if build cache these guys, right? Like your standard. Right, so 200 lines there. It's not a lot. Just for a which saves that to disk and has serialization code. That's like 1,500 lines. Something. But yeah, we've got a few of those, right? Just 1, 2, and but yeah, we've got a few things. Now, what could we do? So what else takes long about the build times? See all the header file stuff. It does link to libraries, but that's probably fine. So we could try a TinyC compiler. TinyC compiler is another. My face. So it's fully C99. Does it do any C11s? Like this thing is probably going to be much faster, right? So we could say TinyC compiler, right? Incredible, 9 times faster, right? So this will get us in the ballpark of under a second. Does it support what am I looking for? Any C11? A portion. Generic. I think we use that stack. So yep, we use that. Yep. Red local, nice. That's cool. No return. Does it support the unnamed? What about unnamed unions? Union members. Something like that. And yeah, it's anonymous, isn't it? It does support that. That's great because that's a C11 feature. Right, so it seems like we could probably use TCC, but I wonder if the error messages are terrible or not. Maybe they're fine. So we integrate this into the repo and compile the code with TCC, then this would make the compilation speed far better. Only for debug builds, right? It's not going to be a release compiler. Use Clang for release, right? But then the problem is you might want to compile with -02 sometimes anyway, right? On some things. So, right. How could you make a C program because obviously you can multi-thread it, right? But then you got to make sure your header includes and not just including the same stuff over and over again. And then you do a single-threaded linker at the end, which is another thing. So yeah, obviously reduce the amount of work paths to do. So optimize your headers. Yeah, we know that, right? So we can reduce the header size. Incremental builds. Yeah. The compilation units, obviously. Separate code into modules. Maybe. Yeah, but the link time will be increased as well. Right. Okay. So we could break it down. So there's a few problems that we kind of need to fix then. So I think we can mark this as being done. There's just a few other little things we want to do. Where can I jot this down for a minute? Right, so the things I want to get done are something like we want to remove the dependencies. So in CodeGen, this currently includes the code generator. It currently includes core, OS, and this stuff. So anytime you change the operating system layer, it rebuilds the code generator, then it rebuilds all the code generator files, which then rebuilds the whole game. Ta-da! It's terrible. So we want to just inline everything manually into here because there's not that much stuff using it, right? So we want to sort of remove dependencies to dependency on the engine, right? So this obviously reduces the it makes the compilation quicker. Take less time. Makes the compilation take less time. And stops rebuilding. All the code gen files and then the whole game, right? So that will be a really good one to do next time. The other thing as well would be we should probably see how much of a pain it might be. See, where is Windows.h being included? So this game main in Windows, so the operating system layer, right? And then maybe Vulkan, right? Yeah. I wonder if we need it in Vulkan or not. But yeah, I think I want to maybe do a custom Windows layer. It might be a big pain, but it would save 300 milliseconds, right? But then again, if the OS layer is already compiled and it's not being recompiled and just gets linked, then maybe that's fine. Yeah, so might take too much time. The quicker thing would be to break GPU and Windows into their own DLL. Sorry, so their own .o file, and then link that in. Just link it in with the rest of the game. So we probably want to say put OS and GPU into the same .o file, since they include windows.h, but nothing else does. Then we can, link everything else in another .o, and then link them. Now I think we can use the rad linker. Is the rad linker the fastest linker on Windows? Is that true? No, it's not the fastest linker. Highly specific character. Jump fast link in LDD. Is it really? No, but it's one of the fastest linkers in a highly specific category, linking massive x64 debug builds with huge PDB tables. The general purpose linking are broadly considered the fastest production ready drop-in replacements. Right. We're using the Clang toolchain anyway, so it'll be easier just to drop that one in. You don't really want to specify your... sorry, what was the question around, do you don't want to specify your search for hot reload? What, when I searched into here and it's mangled with my hot reload stuff, maybe. Because that could cause problems, right? I'm confused. Confused, Colonel J. Right, could it cause problems for hot reload? I don't... No, because these are going to get... link them into the DLL. Yeah, so I'm just trying to... I'm trying to improve the speed now. I'm just... So this causes problems for hotcode reloading because you change a C file and it will like rebuild the code gen and try and rebuild absolutely everything, making it take so much longer because it's got to rebuild the code generator, which takes a second, and then rebuild the whole game, which takes like 2 seconds. So it adds like, so that's 3 seconds, right? Or even 4, because it has to run the code generator as well. Not good. The OS and GPU layer both include Windows H, which adds 300 milliseconds just to include this file alone. And we're not going to be rebuilding this code anyway. Sorry, we're not going to make many changes to the OS and GPU layer anyway. So it's not worth recompiling that source code over and over and over again. So maybe, yeah, and then we want to like link it together. So put them into .o files, then link them into a DLL. Then when that DLL changes, it tells the game, then it reloads. So it shouldn't break the hotcode reload if that's your question. So in code modules, we've got all these guys, right? So we should probably actually put the rest of the game into put everything else every other module in the engine. Put every engine in another DLL into another .o file, right? That's it. Then compile game.c into game.o, so specifically the game code only. Right, and then finally link them all into the DLL. Right, so now we're just paying a link time cost, and that should be under a second maybe. So yeah, game code, then link, sorry, compile. Typically we'll just recompile the game code and then it will link, and that'll be quicker. So obviously for when we do like a release build, you could do link time optimization, but it's probably better just to do a single compilation unit build, because then it has more context, I think, and it's able to do it earlier. Or maybe it's not got more context, but or yeah, it has the context before it stuffs it into the LLVM code into a .o file, and it can optimize it before, and then we can avoid LTO. Oh, I just had experience. That's all. It's yeah, it's been doing it for a long time. But yeah, this will get us down to a sub-second build, and we can test out the build system to do .os, and those .os will compile it. You know, there'll be dependencies on DLL and all that. So that'll be cool. So I think we'll move this into the build system, and we'll literally do this. Oh, we need to remove the old code anyway from the build system. So it's not, oh crap. There we go. So yeah, the build system is technically not done, but we said it was done today. But anyways, there we go. All right, here we go. So cool. And then we'll remove the old code from the build system completely, because it's just commented out and it's just adding noise. Right. So I reckon we can get this done next stream. And that'll make our reload times super quick for the game. For the game code, which would be very much needed. Can we run anything which would check the static? Find all the static variables. LLVM, PDB util, dump globals. Huh. Dump bin. Ouch. Right. Build. Package debug. I want to see if there's any more missing. Libgame DLL. Oh, you gotta do that stupid thing, haven't you? Where is it? The developer command prompt. Because everyone else is not a developer. C users me. Package debug, right. Right, it's not very useful. I want to look at the so PDB util, is that a thing? Nope. Oh, LLVM. Nope. But once we do .o files, we'll be able to see any more statics that we're not backing up. I think we've got them all. I think we have them all, but because it's not crashed yet, but maybe there's one or two lurking which we've not caught. So we'll be able to see that next time. So we want to do... We also want to run... on the .o files. Game, engine, .os or whatever, yeah. So... to find all the stack variables to backup and not crash. Beautiful. Cool. That'd be awesome. So yeah, I think after we've done this should hopefully be next stream. So this will be on Tuesday. Then maybe Thursday we can try and get I've been playing around with something. Thank you so much, sir. Glad you enjoyed it. Where are you gone? Where is it? I downloaded a thing. Did I call it bin? Yeah, I called it bin, right? It's in the bin. The magic of voxel. So we're doing voxel graphics for like prototyping. So the idea is that we can take these vox files and import them into the engine. We want to add that in because that will be very, very useful. So I can use this to like edit the voxels, right? And then just save it and then hot reload straight into the engine. And this will be like super powerful. Rather than building it in the engine, just use this. It'd be quite easy to hook up because I've got the format online. So maybe we'll do this on Thursday, or if not Friday. And in the meantime, I'll hopefully get some time to work on the presentation and maybe get to do it. It should be definitely released this month on YouTube somewhere. But yeah. Cool. In the meantime, guys, if you want to support the channel, get access to the code to run on your own local machine, you can support the channel support the company, the studio, over at Ko-Fi. Thank you for everyone who's supporting the studio already. Appreciate you all. And there's a Discord if you want to come and chat in the meantime. Talk about all sorts of things. Talk about programming. Talk about the Bible. And yeah, you can even share stuff you guys are working on. Ask questions, whatever. And yeah. Yeah, at least we got Hotcode Reload working pretty well today. Right, take care, guys. Thank you so much, Colonel J. Appreciate you. Yeah. Check out the stream schedule down below. And I'll see you all very, very soon. God bless you all.